Hello, everybody, and welcome to the first deep funding team meeting of 2023. Happy New Year. Well, it's not that new anymore, but happy 2023 in any case for all of you, and happy and successful and healthy, I would say. We have a couple of people here, and some of them would like to give a short presentation of the status they're in. And I would like to start out with Alessandro. ZRush.
Yes. I'll share my screen. Actually, first I'll do a bit of a recap. So basically what we've been working on, in the last few weeks, we've been focusing mostly on writing a new proposal for round 2 of deep funding, which we will upload soon, as there's not too much time left. I will maybe go briefly on what we're thinking on that. Then we've been working, so we completed the design part of our system, and we're working on basically now the main focal point, which we have a bit of ongoing work, which is the creation of this 3D mapper, which we've been testing a few different algos and available systems. We've been tweaking them a little bit, and there's still some work to do. So we have some performance issues on them, and I feel like a few of the ones that we tried don't have. We didn't manage to get the resolution that we want. Not resolution, but the images are not the best how they end up with. But we're working on them. There are improvements. So I will keep you updated on that. What we did in the meantime was to do a 2D version. So I can show the screen, which has both the design and the 2D test that we made. Did I share it? No.
Yes, we see it now.
Yeah. So basically, this is how we would like to have the final system, at least the design of it. We had shown you some prototypes before. This would be the final, more clean version, where here we have icons. Actually, we have those icons as well. We just don't have them in this file. Where here you can just push the buttons to select the actions that the drones will do. Here you have the drones that you have selected that you will see in the map. And here in the bottom left, you have the zoomed out map. So what we have here, we took this test data set, and we did this reconstruction where this was made out of 40 pictures, and we stitched them together. They were all aerial pictures taken at the same altitude, and this is easy enough. So let's say that one version of it could be just creating the map from a 2D aerial view. Now, what we would like to do with this and what we're working on is to be able to zoom and move it so that you can see it in cross section, and you can see how high each of these objects are, so that when you navigate the drones, it's not only in 2D. I would say that for some use cases, this might be already doable, but we really want the 3D to be able to control them a lot more accurately, and also to be able to get those 3D models of the environments, which we think it's pretty valuable to have those 3D reconstructions. Now, this would be the other screen, which is so basically here you see the whole swarm, and you would be able to control them as from a top-down view. And on this other screen here, you would have the live feed from the camera of the drones. On the bottom left, you would still see the mini-map with the position of the drones. And here we have some commands and some of the things that the drones might, that you want the drone to be able to do. So you have like storage of how much storage they have for videos and data and photos. You have battery level, GPS level, the Wi-Fi connectivity. You have some information like height, speed, and you have the actions to here to record images. So once you go into this view, which is a first-person view from the drone camera, you would be able to control it and basically take pictures and videos, access the gallery, and so on. We also put these buttons here, which are tab buttons, so that you can switch from one drone to the next without having to go out again every time in the other view and then click into the drone that you want. So by clicking these, you can tab through the drone's cameras and see what comes up. And now what we're doing with this is that we are coding this. So hopefully next time you will be able to see this in motion, as in, because we are putting all of these icons, we're putting all of this design into our simulation, into our Unreal Engine simulator. And we have coded most of our basic controls in the simulator. So we have a way to select the drones in the way that we want, which is drag and click and drag to select multiple ones. We have the explore area, we have the buttons, we have the actions coded to gather the data and create the map, and also the one just actions to move the drones without creating the map, because as we've seen, this, especially like creating the 3D map, takes it's a long process. We are not we're not so sure if it's feasible from a cost perspective to do it real time, so we might have to do it so that you first send the drones on the area that you want them to work on, you collect all the data, you remap everything, and then once the map has been created, then you would move the drones. But maybe we're not so sure if we can do a real-time generation of the map. So we are investigating that. So that's where we're at.
Thank you, Alessandro. That real-time 3D thing, is that so I can imagine for presentation purposes you would like to have that really cool and really well rendered, but I can also imagine that while you are in the air with the drones, then it's more for navigation purposes, and then it could be much more low resolution. Is that correct?
So the one that you have seen, this the top-down view, this is doable in real time. Mm-hmm. What we are struggling to do in real time, and which takes a bit of time, is when the map becomes 3D, so that you can see it, you can see the heights, and you can move it, like you can switch it from just top down to looking at the sections, and it takes a lot to render. So we are trying with increasing the machine power, but for now, at least with our machine, which is pretty powerful, it doesn't work real time. It takes actually a few minutes to reconstruct, to take 200 photos. I'm not sure how it's going.
Yeah, I suppose that's an evolution, right? You could start with this view, and then at a time you're using your drone to rescue people from caves and flying under bridges, etc. Maybe by that time the industry will have evolved a little bit further, which will enable you to do more things like that.
So yeah, that's an option. The other option is, well, for example, in that case, you could just use that if you need to rescue people. I mean, let's say not in underground sites, because that creates a whole series of different problems. But if you can see them from, let's say they're lost in a field or something, if you can use the 2D mapping, and then if you have to go into, let's say the drone needs to go down or go in an area with obstacles, you could switch to the front first-person view of the camera and control it as a normal drone, so you wouldn't have those issues. In let's say when I'm saying that we are able to do it in non-real time, it's for some use cases where, for all the use cases where the area where the drones would work in would be the same, then you can run them once on the whole area, map the whole area, take 20 minutes to render the area, half an hour, depending on how big it is, to render the whole area. And then you would have the map, which means that then in the future, you would be able to operate them in the looking at the 3D map. So let's say if it's for agriculture purposes, you would be able to see the map. You would be able to move move the drones on the field, recreate the whole map of the field 3D, including all the obstacles, trees and houses and barns or whatever. And then you would have that map stored, and you would be able to move those drones on the map.
And suppose I would be recording a football match or a festival with some kind of thing. You could set your drones loose on that area and have them flying around and recording. But then afterwards, you could render that into a 3D environment that I could see then later if I didn't attend to the event?
Yes. Yes. So what we haven't tried for now is having moving objects inside so we haven't tried with people moving or running around. So in the case of a football match, what I would say, I would say that the way to use them would be that before the match, when no one's there, you run all the drones on the stadium, and at that point you can render the stadium and you have your 3D image, and you know that the stadium is not going to change. Like, there's going to be people in it. There's not going to be other moving parts. That's the stadium and that's it. Then you move the drones on top of them. Like, you move the drones, and if you want to take videos or take pictures, then yes, those videos are normal videos, so you don't need to render them. So you would be able to see the match on a later stage from those different angulations. It would be more like moving cameras. So I don't think that you would be able to see the full match as a 3D image where you can look at it from whatever side you want. But you can see the stadium from whatever side you want. So for any even for training purposes, or what we thought that one good use case, which goes actually around all of these, and which is where we're focusing our next proposal, and it also came from all these conversations in these meetings, is to render objects and whole areas of environments for metaverse purposes. So that basically solves all our problems, because you don't need the real time, you don't have moving parts, and you would be able with a swarm of drones to actually, let's say, if you're able to run them on a town, you can even render that whole town, or render a neighborhood, or render a building, streets, or whatever. So that would be a pretty nice use case that kind of helps us with the obstacles that we are finding.
Yeah, so it's a journey, and you will encounter stuff, and that's R&D, and you will find solutions, and this is just the start of a journey. But you're making progress, and I'm looking really forward to the next step, where you will be able to show us the can't think of the name, the tool inside the metaverse, and then actually controlling the controller these drones.
Thanks.
All right, thanks a lot for the presentation. Anybody else? Some questions or remarks? Ken, of course.
Sorry, yeah, front of the class. I'm curious, when I'm trying to reconstruct cities using tools inside of Unity, there are a few programs that'll access coverage maps and try to build up roads and areas of grassland and so on from that. Is there any utility with your goal to create this in a metaverse? Will there be connection with existing coverage maps that might help inform the 3D objects in a metaverse?
So yes, and let's say in open areas, we are also looking at how to integrate with even with satellite images or with Google Maps, Google Satellite. We've been looking at that to see how in open areas you can maybe start with an already made map. So yes, I would say one of the best uses would be to that you can even recreate indoor environments or like more specific. So we're kind of looking at it. I'm not that sure of the answer right now.
It'll be cool to see this in two ways, both within and outside of a metaverse, if it goes in that direction. To be able to work in a lab, as it were, a virtual lab, and then the effects on the drones in the real world taking place. It would be pretty wild crossover. If I'm in a metaverse, for example, visualizing the positions of drones and making changes, and then those being affected on the real drones in the real world as well, it becomes kind of like an organization center of sorts in the virtual world.
Yeah, no, okay, I understand what you're saying. Yes, that would be. That would be useful. But we're still looking up at these things, so I'm not too well equipped right now to answer or.
Well, having watched far too many science fiction movies, it's really easy for me to ask it, but it's a whole other thing to make it.
Yes, there's also a candidate in our deep funding working with satellite images and creating layers of information on top of that and putting that out as a service. I think that is quite a promising proposal, to be honest. Don't have the name. I think there are two, but one of them is specifically interesting. So if you would want to, and they also have something where they increase the resolution of images. That is part of their solution. So maybe I don't know where the synergy or overlap would be, but maybe it's good to check it out and see if there could be some interesting angles for you there.
Definitely. I'll look it up.
All right. Thanks a lot for this presentation, Alessandro. Always great to see presentations on the drones. Great. Ken, I think you also had something to show or tell us.
Yeah, I have an exciting few pages of text to discuss with everyone. Have created the lobby one-to-one instructional room with an avatar and 4 worlds based around Carbix's X2 carbon capture unit. So we can teach how it functions, how it would be used on location, and so on. So now we're moving into the section where we're developing the AI services. First of all, to work with adaptive learning. And we're working with a gentleman external to our companies who suggested that we take a look at divining the complexity of a question. So we're going to base the form of our data set on a Kaggle form, which is a Psi Q&A. It's basically a question, a correct answer, 4 incorrect answers, or 3 incorrect answers, and a lecture. So what he's going to do is build a synthetic database for us that will represent students' attempts at answering the questions accurately. And what he wants to do with that is being able to provide a service where we would put in a lesson, or a person would type in a lesson or a course, a series of lessons. And this will be the first stage of producing a recommendation engine by understanding the complexity of the lessons. Now, as project manager in this case, I'm directing him towards keeping in mind that this will be a series of lessons. So we need to know what the prerequisite question would be for that particular lesson and what the following options would be to choose a more complex or less complex lesson to follow. So at this moment, he's building the model to pull the complexity of a question primarily using language processing. And we'll go from there. And he's been generous enough to create a short document for us that outlines what it is he'll do, which I can show. It'll be a very exciting scrolling of a text document as a screen share. But to read it, basically the aim will be to build a recommendation engine tailored to recommend the best questions to ask a student based on their learning performance. And he's broken this into 5 areas. First one, personalization. It'll recommend questions based on the individual student's quickness and accuracy in terms of answering a question, for example, to try and gauge their ability if something should be repeated or not. Adaptability, to adjust the difficulty of the questions. Efficiency, by recommending questions at the most appropriate level of complexity, he writes, the engine can help learners focus on the material most relevant to their needs. And I suspect what he's going for there is to understand semantically, in some degree, what the subject matter will be, as well as the complexity, which I think will be a tall challenge to pursue, but very exciting if he can do it. From my own limited experience in NLP and linguistic tagging, I suppose that could be possible by looking for n-grams and combinations of important words, important names, proper names as it were, and perhaps verbs as well. And he's recommending, of course, the improved retention that we're all familiar with in a 3D environment, and self-directed learning. So we're trying to build something that's reasonably random access, but it needs to have enough structure so that a course is proceeded through in terms of a knowledge graph, informed by the student's choices. Now, he writes that the question complexity estimation, NLP, natural language processing techniques to predict the complexity of a given text. He's going to then start building the recommendation engine itself within Python. And for building the modeling and computing the modeling, we're using Google services at the moment. He writes skill extraction. And my apology to everyone for reading this. This is slightly outside of my area, so I need to kind of follow rather slavishly the text on the screen here. The skill extraction, he'll be identifying and extracting the skills based on the topic, like biotechnology, mechanical engineering. The reason those are there is because of the SciQA database, which is about 20,000 questions, covers all of these areas. And we also want the service to be generic enough that a person can use it for multiple topics, not just our topics, for the carbon capture unit. That in itself deals with areas of engineering and, of course, chemical reactions and physics. Let's see, he says they'll be using a spacey or zero-shot model to build this module. And if anyone understands what that actually is, I'd like to hear your information on this. It sounds very... It sounds like very something I don't know what it is exactly, but we'll find it. The recommendation algorithm, he writes, the next possible question will be made using hybrid algorithms, which are a combination of content-based, collaborative recommender, hybrid ones. So we do have a script of carbon capture unit specific questions, but it's a very small data set to use to build a model. So he's building a synthetic database to accompany that. So in that sense, it'll be hybrid. He's recommending that the algorithm will take into account input features like a current input question, the answer, the complexity, the skill topics, whether it's chemistry or operation or what have you, the student's historical correctness, how accurately and correctly they answer the question, and the vocabulary. Now, to begin with, when I started this, being well aware that we have so many modules to cover to build this learning experience for a student in the metaverse, I limited it to multiple choice questions and very specific languages. I think what he's building is going to give us more latitude in terms of what the student will be saying or reacting to with their answers. And I think that'll be beneficial. And then he describes the architecture, which is the most fascinating part of this document. It's question and response, the knowledge base, complexity estimator, skill extractor, and I can show you this. That's combined, and then a hybrid recommendation output is made from that. So I'll stop there so as not to take you on this text journey in such an abstract manner. But what I can say is that we're well into building the model for the AI. We're aiming for an imperfect model. We've produced an API endpoint and a static JSON format for me to begin working with within the Carbix metaverses. And in parallel, this gentleman will begin building the model for our AI. So before this, I was very secure saying, yes, we've got the metaverse. It's going to be great. And then we get into the AI portion, which drifts beyond my experience. We're fortunate enough to have someone who has a vision for what the model will be. And that'll get our footing in the right area to start building the adaptive learning side of this set of services.
Wow, that sounds really impressive.
It's a bit of an avalanche of dialogue. Thank you for listening.
That's fine. That's fine. That's fine. So the recommendation engine would recommend the next question that a student would need to answer that would be appropriate to their skill level and experience and the topic, etc. And that way guide the student through the curriculum.
That is correct. Now, because he's focusing on linguistic tagging or natural language processing, I think the opportunity is also there for the lecture part of the dataset to pull out sentiment. And we can match those sentiments to specific tags that can then inform the avatar teacher what kind of mood they can take on for the description. If we, and this is off the top of my head, if it recognizes sentiment as seriousness or technical or relaxed, we can then kind of gently transfer from one of those sentiments in terms of avatar animation and body language into another. So there's a randomized but sense of free-flowing communication. Now, where this will get particularly challenging, I think, is if we need to pair it to showing operations of the machine or the avatar operating the machine in some sense. I know we'll be fine for the text side of it, where we're answering in multiple language, but we also need to pair it to animations of the X2 operation, for example. We do have an advantage, and then I'm told the operation is press this button and then press that button. So it may not be that challenging. But what happens within the machine in terms of matter transfers from gas to liquid to solid slurry, I think will be particularly interesting. So we're going to have several levels of presence and information, I think, in the end from this, starting with this initial adaptive learning.
Wow. How generic do you think this whole recommendation engine and all the logic around it will be?
We're trying to make it as generic as possible. The instruction I gave him is that prepare this as if it were going to be used on a website where it's purely text-based, perhaps with images or video. But keep it that simple because it'll be our job to interpret this, whether on a web page or in a 3D environment or paired with video and other text material. So theoretically, a person can use this in an online course in the standard sense that we're used to, since the delivery in JSON is primarily text-based, perhaps with URLs for pictures, or they can go to the situation we're in, where we ingest that JSON information and then interpret it within the 3D environment on our side, the presentation layer, to show the animation. So we're trying to make it as flexible as possible by starting as simply as possible.
Yeah, I don't know what to say. I mean, it seems like the stuff you're building around the content of the education is so much bigger, deserves so much more than just the topics that you are targeted on, which are important topics. So, first of all, one thing I'm thinking is I will share this with somebody that we're partnering with in the educational sphere to see if they might also be interested in this approach. So will this become a service on our platform, that recommendation engine for educational material?
Yes, it is. That's what we're designing it as.
Yeah. And then would somebody be able to feed it with their own educational content? Okay.
Yes, I've instructed our programmers to keep in mind that this will need to be adaptable to other content. So he's using a hybrid or synthetic database to help accommodate that. It covers a series of questions. And ideally where I want to get to is for a person to be able to input their own custom lesson in the system and then have it assign a complexity or a challenge level to each question involved. And then in addition to that, we also, of course, have to have some sense of progress in terms of prerequisites and following questions. So it gets a bit complex in that sense, and we're just at the beginning of it. But we are designing it to be a service and to be generic enough that people can use for their own lessons. Now, in my science fiction brain, what I'd love to see is a person be able to input raw text and then have lessons built from that. But I think that would be another project altogether. It's stuff to keep in our mind, to build lessons automatically from text sources.
Yeah. Yeah, well, education is a very interesting topic, obviously, and in the metaverse even more so. This is really a project in a project, right? So this is a big thing in itself. I think we see that more in other projects as well, also in Alessandro's project, where the 3D rendering is a project in itself. But here I think you have three projects in a project or something. There's the sign language, there is the educational metagraph recommendation engine, there's the whole 3D environment, and that all around that carbon product. So yeah, you're building a lot of stuff, Ken.
I have to tell you, I really enjoy it. I've always been had a predilection towards visualization since even before I could speak coherently, I think. And this is an opportunity to kind of see the challenge. I don't know how to describe it in terms of motion within motion in a three-dimensional sense. If we were to imagine solving a problem and being able to position ourselves in time within the evolution of that problem, we can begin to plan the complexity. And the way my mind works is a little bit, there's almost like in terms of music, you have repetition and you have forms within forms. And that's how I envision it. Of course, which means nothing if I can't organize it. So that will be the real challenge. Alessandro's project is particularly interesting because it takes place in the real world, whereas I'm positioning mine in a virtual world that can follow whatever rules we need to. So.
Unbelievable cool. Kenrick, you have your hands up.
Yeah, I have a question for Ken. I'm curious how you do the 3D modeling from a physics point of view. And I'm asking the question particularly because many years ago, I came across a really elegant approach to multidimensional analysis called geometric algebra. And it's still not well enough known. And so let me pause. I have more to say, but let me just ask the question first. You know, what sort of physical models are required for the 3D animations you're working on?
That's an excellent question. Currently, the models are based on SketchUp models, which Quincy from Carbix is creating. We're then passing that over to a young man who's just graduated, who's optimizing it in terms of the texture mapping and the pivot points of models, optimizing so we can use it in real time. The X1 exists as a physical prototype, and the X2 exists as a three-dimensional model currently. I hope that you will explain what you're describing in terms of...
I'm going to give you a link, and this might be drilling down into the details too much. You know, in other words, you may be using tools that would have to build this rather than wanting to build these tools yourself. But it turns out, you know, for the physicists in the audience, and we've all taken courses in vector algebra, but it turns out that the curl function, which expresses rotation, turns out to be a bad way to model rotation. There's another function that's closely related to it called the outer product. So the inner product people, I think, with basic knowledge of math and physics have maybe familiar with the idea that if you have two vectors and you take the dot product, you get a scalar number that has to do kind of with the intersection of those two vectors. And then, but it turns out you can form what's called an outer product that essentially defines the two-dimensional space formed by those two vectors. And it's a real, what's powerful about it is that as opposed to the curl, which is sometimes called a pseudo vector, this really does give you what they call a bivector representing the two-dimensional space. And then from there, you actually get a very elegant way to model any number of dimensions, whereas the standard calculus approach breaks down at 3 dimensions. You can sort of make 3 dimensions work, but beyond 3 dimensions, it doesn't work. And then, but the thing that gets even more fascinating about it is that in this approach, if you add the dot product and the vector product, you get a new function that they call, I believe, if I remember correct, they call it the geometric product. And that geometric product turns out to have an inverse, which both the dot and the cross product and the curl products don't. And it's another part of why it's not a complete algebra. But once you form that geometric product, you have a complete algebra of high dimensional spaces. And I think it's going to take a while for this to really catch on, but it goes all the way back to the 1800s where this mathematics was actually worked out. And then we historically made a bad choice, and we've suffered under that bad choice for 100 years, 150 years now. But there's some new physicists that have been trying to resolve that. And the link I gave you is specifically for computer science and doing 3D, multi-dimensional modeling with computers. So if nothing else, I think you'll find it really interesting. I don't know whether your team would be in a place that it would be useful to apply to your project, but it's completely fascinating.
I'm very much appreciative of this. It sounds very much theoretical and also the alternate path not taken. So I'll absolutely take a look myself and recommend it to our coder. And the notion that we can define reality in these very elegant mathematical forms. I'm not a mathematician at all, but I find it invigorating because it's almost like a language of the universe, a language of understanding reality. And in a practical sense, to use this for models of the X2 is their way to apply it. I'm familiar with dot notation only from 2D animation and 2D game design vectors, for example. So that'll be my little climbing on point.
Right, exactly. Yep.
Brilliant. Thank you. Wow.
Very nice, Ken.
Thank you. Fascinating stuff. I wouldn't dare to comment on it. Thanks a lot, Ken. Thanks a lot, Kenrick. Quincy just joined. So Quincy, Ken, your colleague, just informed or told us, explained us about the recommendation engine. And I'm really, really impressed by the scope and magnitude of that and ambition of that part of your project, which, as I mentioned, sounds like a project in itself, but also something, if we can make it generic, would be very useful for a lot of educational purposes. I was thinking you could almost, with the things that you're building, offer something like education as a service, where you infuse content from others, but then put it to work, create an environment on it, create a recommendation system on it, and then put it out as a course. And then Carbon could be the first iteration of that, but you could help others to do something similar.
No, I definitely agree. So I mean, we're still building the prototype right now. It is obviously involved, as Ken already shared. But we've got a pretty good ML programmer that really understands the project, and I think that was important when we were meeting with coders and a couple different programmers. Yeah, it was very cool that he understood it, and we have a few more that we're going to work with towards the end of the milestones. But yeah, so far we're happy with with the development that we've done so far. But it'll become a bit more challenging as we go along, but we're ready for that.
It will be a journey, just like all of us are on a journey, but having the right people on your team is essential. So I'm really happy for you that you found the right person for the right job. So that's already
For
been
now. Right person for the right milestone, I guess.
all right. Great. Thanks a lot. Is there anybody else who would like to do some presentation? Then in that case, we'll end that part for today.
Well, actually, I don't know if you want to record it, but I can give an update. And
it's still recorded, so we can.
Oh yeah, everything. Oh, fine. Well, I can give the update on our team. So, as I've explained in other updates, we've had a lot of challenges integrating our applications into the publisher. So the current status of that is the following. We have an exceptional engineer on the team now, and he is leading the effort and helping the other members of the team to use the command line interface. And through the command line interface, we first demonstrated just the ability to send text back and forth. And we now have the ability to provide the actual input files needed for the application, and then it sends back the resulting image. So that's one part of it that's demonstrated now, is the proper inputs and outputs for the application. And then on a second part of it, we've been able to demonstrate a transaction, of what we just set it at 0 AGIX to begin with, but we did execute a transaction, again, using the command line interface. And our next step is to kind of integrate those two things so that the app would pay for the service and show it. The area where we're really still stuck is in using the AI publisher. The tool basically the tool doesn't let you go backwards. And without going backwards, if you make a mistake, you're stuck. You have no way to undo the mistake. So we have registered, I think, 4 different organizations on the publisher now. And we've deleted a couple of those. We've tried to clean it up. We've deleted a couple of those using the command line interface tools. And for a couple of them, I think that seemed to work fine. But we still have one organization called Fotrek, LLC that's stuck on the publisher that we tried to delete with the CLI, and it didn't feed back to the publisher. And then we have a second one, Fotrek.LLC, which we thought was clean. Like, that's our latest version. We were making progress with it. We had to set up new emails so we had a new affiliation, but we thought that was where we were going to demonstrate everything. And then today, the owner of that organization said that for some reason, everything's disappeared or been reset on the publisher side. So I set up a meeting for tomorrow with Michael and his team. It is critical. Like, he wasn't sure whether it was necessary to have another meeting. From my point of view, it's absolutely critical. If they somehow resolve this in the next 12 hours, maybe it's not necessary. But I think it requires one of their technical people, live with our technical people, resolving this problem before we can actually get the DApp to work. We will try, and one of our next steps, as I explained, we will try to get the DApp working just using the command line interface, and we might end up having some success with that, but thus far we're stuck. The AI publisher we're really stuck on.
Thanks, Kenrick, and we will support you on that. And if a meeting is the best way, then we have a meeting. The only thing is that we want to use the time effectively, so not just have meetings because of the meetings, but we already mentioned if a meeting is the best way, then of course. So things are surfacing due to this experience with people onboarding services. And we already understand that the onboarding process itself is something that will require more attention from us to improve. Very, very happy that we also have in the meeting here our friends from Zero to AI, not Zero to AGIX as you mentioned, but Zero to AI. Are there also with great ideas, and not just ideas, also engineering, who I hope will be helping us also very substantially with that challenge. So I'm actually quite optimistic that within, let's say, next half year, we will be substantially improving the onboarding process through this way and maybe through other ways as well. In the meantime, we will help you. And yeah, we'll get that done. One way or another, we'll get that done.
Very good.
All right, then with this, I will stop the recording for those viewing this later. Thank you, and be back in 2 weeks.